In this video, we will be solving systems of equations using the elimination method. So recall that a system of equations are two or more equations with the same set of unknowns. For example, these two equations, 2x plus 3y equals 15 and x minus 3y equals 3, would be considered a system of equations. Notice they are both written in standard form. Typically, when we use the elimination method, we write the equations in standard form. So the solution to this system of equations would be the point at which both lines intersect. And in class, we've been practicing graphing equations. So if we graphed both of these equations, wherever these equations intersect, that is the solution to the system. So in other words, to solve a system of equations, we have to find a value for x and a value for y that satisfies both equations. So let's come back and look at our two equations. When we use elimination to solve systems of equations, what we're literally trying to do is eliminate one of our variables so that we can solve for the other variable. So in this particular situation, an elimination involves adding the two equations together. So in this example, notice that if we add 2x plus x, we get 3x. Then if we add positive 3y and negative 3y, we get 0. We have eliminated the y's. So 2x plus x is 3x, and then 15 and 3 is 18. And then if we divide both sides by 3, we find that x in this situation has a value of 6. So then, if we know that x has a value of 6, we can go back and we can substitute in 6 for x to solve for y. All right, so we already know that x has a value of 6. So now we can choose either equation that we want and solve for y. Let's choose the second equation. Instead of x, let's put in 6 minus 3y equals 3. Let's get rid of our positive 6, so negative 3y equals negative 3. So y has a value of positive 1. And again, it doesn't matter which equation you use. I could have said 2 times 6 plus 3y equals 15, 12 plus 3y equals 15. So 3y equals 3, and y would still have had a value of 1. So when x is 6, y has a value of 1. So we know that the point of intersection, or the solution to these equations, is 6, 1. And if we were to graph both of these equations, just like we've been doing in class, then you would be able to see that the point of intersection is 6, 1. All right, let's go ahead and try another system. I have two equations here, and let's go ahead and see if we can eliminate one of the variables. Well, the first thing that I notice is I have 2x here and a negative 2x here. Those zero each other out, so we have eliminated our x's. So now we have 3y's and 6y's, and that makes 9y's. Then we have a positive 15 and a negative 6, and when we add those together, we get 9. So we divide by 9, and we see that y has a value of 1. So we know that y has a value of 1. So now we choose an equation, and we substitute 1 back in for y. So then I'm going to go ahead and just choose the top one. 2x plus 3 times, instead of y, I'm going to say times 1 equals 15. So 2x plus 3 equals 15. I have to isolate my variable, so 2x equals 12, divide both sides by 2, and I see that x has a value of 6. So the point of intersection for both of these equations would be 6, 1. And again, we could graph that to prove it. And as always, review this video as many times as necessary to ensure that you understand the concept, because we will be expanding on it tomorrow in class.